Hey guys, this is the video for chapter 8, lesson 2. In this lesson, what we're going to focus on is using the distributive property to factor the greatest common factor. So that's our goal today. So previously we talked about factoring out a monomial into the greatest common factors, right? So if we have a 15W, this would be 3 times 5, right, as the factors. And so that would be 3 times 5 times W to make 15W, right? So 3 times 5 times W. And then 3 times V, 3V would be factored out as 3 times V, right? And so what we can do is identify what they both have a common like multiple of or a factor of. In this case, both of them, when you factor them out, have a common factor of 3. So we're actually going to bring that 3 out and then put in parentheses 5W minus V. So in other words, we are actually doing the opposite. We are turning this into a problem now with a parentheses. And so if we distribute this out, it would be the same thing as the original problem. It would be 15W minus 3V. So you can always check your work once you've gotten factored out the polynomial into most simple terms and you distribute it back in, it should be exactly the same thing. So looking here, I have a 7, a 21, and then I don't have a coefficient here. So when I look at this, I can identify, okay, like 7, 7 would be, the first term would be 7 times u times u times t times t. The second term would be like 3 times 7, right? Times u times t times t. And then our last term would be -1 times u times t. So we can identify that actually all of them have just one u and one t in common. This is kind of like what we did in our previous lesson. And you might get to a point where you can just look at this and see, well, what can be like brought out of these terms is just the u and t. That's like the minimum that they, or I guess the maximum they have in common. So we'll bring the u and t out and then put in parentheses 7 u t, because what's left is this one u and one t, plus 21 t, because if I look at what's not highlighted here, the t is not highlighted. And then I'm going to subtract 1 because I actually did not bring out this coefficient of -1 here. So the factored out version would be ut times 7 ut plus 21t minus 1. If I distributed this, I would get the exact same thing as what's in problem B. All right, looking at C, if you can kind of identify a common factor amongst the three, it looks to me like 3 is a common factor because they're all divisible by 3. They all have at least 2 x's in common, right? The least degree, they all have a variable of x, but then this is x to the second degree. So they all have a minimum of x to the second power. So if you wanted to, you could factor everything out like we did earlier, highlight what they have in common, and that would be what you bring outside the parentheses. What's not highlighted would go inside the parentheses. So here, I know I'm going to try to think 3 times what is 9? Well, 3 times 3 is 9, and then x to the second power times x to the fourth power would make x to the sixth power. So I'm going to leave it as x to the fourth. Then I'm going to add 5 because 3 times 5 is 15. And this would be x to the second power. And our final term, 3 times 4 is 12. So 4 is what's left. And I do not need to have any variables because the x to the second power is already brought out. And if you wanted to double check, if you wanted to do it the way where you factored everything out, you definitely could do that, right? 9x to the 6 would be 3 times 3 times x 6 times. So I'm just doing this the long way. And then 3 times 5 to make 15, x 4 times. And then 2 times 2 times 3 times x, okay? So I'm going to highlight is the 3, 3, and then 2 x's for each. And you can see what's highlighted in blue is what I put in front of the parentheses. What is not highlighted in blue is what's left as the terms inside the parentheses. I'll color code it so you can see. 5x to the second, 5x to the second. 2 times 2 times 3, which is, wait a minute, 3 should be highlighted. So 2 times 2 is 4, and that's what's left here. So if you can see, the blue is what's in front, all the other colors are the terms that are inside the parentheses. Looking at D, all of them have a common factor of negative because they're all negative terms. So I'm going to put a negative as what's in front of my parentheses. They can all be divided by 6. So I'm going to put negative 6. Then the least degree of x to whatever power is x to the second. So that is going to go in front of my parentheses. And then I'm going to think to myself, negative 6x squared times what will make negative 6x to the fourth power? Well, what's left would be x to the second power. Then what's inside is going to be an addition sign because when I multiply this negative, it's actually going to turn the term inside into a negative, right? And so, right, a negative times a positive makes it a negative. So I'm going to think to myself, negative 6 times what is 18 or negative 18? That's 3. And I'm left with 1x. Then I'm going to think, okay, negative 6 times what is negative 12? That would be 2. And in terms of looking at the variables, x squared is already brought out here, so I can close it and I'm done. Remember, if this, just looking at it and doing it like this is hard for you, factor everything out, get some highlighters, highlight all the greatest common factors. That's what's going to go in front of your parentheses. And then what's left in those, each term will be what goes in the parentheses. Okay, what is the greatest factored form of 8t to the third plus 14t to the second plus 20t plus 35? Well, the first thing we're going to do is group the first two terms and the last two terms because we've actually got 4 terms here. So you can also group the first two terms and write this as plus 20t because I'm bringing that sign in with the term just so that when I work this out, it's really I should have the parentheses in, or the addition sign in between the parentheses, but I'm going to put the addition sign with my term so that I can remember that that's a positive. Then I'm going to factor out each group. So let me do that over here. 8t to the third will become 2 times 2 times 2 times t times t times t. Then 14t to the second will become 2 times 7 times t times t. And then I'm going to just do the bottom or the second part of the parentheses as well. Second part would be 20t would become 2 times 2 times 5 times t. And then 35 would be 5 times 7. Nothing. So I'm going to look at these separately as because they're in two separate parentheses. I'm going to look at this as common factor of 2t squared, which means I have 2t squared times 4t plus 7 plus, now I'm going to look at the second set of parentheses. They both have in common a 5. That's it. Plus 5 times 4t plus 7. All right. Now what I realize is that what's in the parentheses are actually completely identical. And because they're completely identical, I know that 4t plus 7 times 2t squared plus 5 will give me the expanded out version of what I'm looking at. Now, I know you're like, where is this all coming from? How do you even know how to do this? Well, I'm just showing you how this is possible. And as we do this some more, you're going to kind of catch the pattern of what we're seeing here. So you see how the blue I brought together and wrote it as 2t squared plus 5. And the pink was what was in common. So that is all being multiplied, right? It's a common multiple, I guess, of both terms there. So I brought that down. And if you FOIL this out, you will get the polynomial that's above. So let's try this out. We got 4 terms. And so let's see, sometimes there is a GCF of all the terms. If so, factor out first. So you're looking at this and immediately you can probably identify all of these are divisible by 3. So when you see a greatest common factor in all the terms, go ahead and take that out first. And I'm looking at this and it looks like 3h is a common factor because all of them have h in common. The minimum they all have is 1h and they're all divisible by 3. So then I'm going to do, okay, 2h to the third plus 3h to the second plus 4h plus 6. And now I'm going to group the first 2 terms and the last 2 terms. So now I'm going to just like bring this down and look at this as 2h to the third plus 3h to the second, close my parentheses, group my 4h and my 6. Now I'm going to factor out each set of parentheses. And so it looks like the first set only has a common factor of h to the second power. So the h to the second power 2h plus 3. And the second one can all be divisible by 2. So it'd be 2, and then this would be 2h plus 3 again. And so again, what we're seeing is that what's in the parentheses is completely identical. This is completely identical, which means when I write this out, to write the distributive property, I'm going to write this as h squared plus 2 in parentheses times 2h plus 3. Now, I'm not done. I left some room. I wonder if you know why. It's because initially I factored out the first greatest common factor of 3h. That actually still belongs in this whole set, right? That didn't magically disappear because we factored it out. It actually still belongs into this. However, we just put it on hold because we had to factor everything else out. So we want to make sure to bring that back down. So if I now use the distributive property to multiply all of this out, you will have the exact same thing as the problem that was given to us. So you could always check your answer by factoring it all out and then, or not factoring it all out, FOILing or multiplying it all out to see if you have the same thing. Okay. I believe we have, actually, that's it. So that's another short lesson. We will do some more practice over this, and we'll start to also read the instructions to help us know, like, what are they expecting us to do here. Anyway, that's all I have for today.